showing you.
I know. All right, guys, it's Monday morning. I'm just going to go over some notes for the 9-4 factoring to solve quadratic equations. So this week the plan will be to get through 9-4 and 9-5 probably. There maybe start on 9-6, I'm not positive. So let's go through the 9-4 notes. Again, continue to check the e-board for updates and the Google Classroom. And we're going to redo that quiz. I'll probably post on Classroom today. It's going to be in Edulastics. I'll probably post that at some point later today, and we'll get it done by at the end of the day tomorrow or something like that, all right? So that first one we took really just strictly a pre-quiz. All right, so the 9-4 notes going forward. There's Angel getting his work done. All right, so we actually started talking about this when we were doing factoring, which is good, so we have a head start on it. The key concept that we have to remember is that anytime we multiply two things together and get 0, one of them has to be 0, okay? Or at least one. That's called the zero product property. So that's the basis of what we're going to do here. We're going to factor, hopefully you recall Chapter 8 we factored. We're going to factor quadratics. We're going to get a binomial times a binomial, an expression times an expression, and get 0. So then we just set either one of those, we're going to set both equal to 0 and just solve them, and there are two solutions. If I were to plug them back into the original quadratic, I'm going to get my output of 0, okay? So when a quadratic is set equal to 0, factor, and then use the zero product property. All right, so here are some examples. I'll take pictures of this too, which I believe I did already, and put online. So if we have our x squared plus 8x plus 15 equals 0, remember our rule, if our leading coefficient is 1, we just think what two numbers multiply to get 15, combine to get 8, 5, and 3, x plus 5, x plus 3 equals 0. Just set each of these equal to 0, and we solve them. X would be -5, or x would be -3. By the way, what we're doing is we're finding solutions to this, which are also called the roots or the zeros of the function. All those things mean the same. If I were to graph x squared plus 8x plus 15 equals y, these would be the values where I cross when y is 0, the x-intercepts. Anyway, then we get a little bit more complicated. Hopefully you recall your AC method of graphing. I have 2x squared minus 15x plus 18 equals 0. I multiply a times c, which is 36, to combine to get -15. Both signs are going to be the same. Both are going to be negative. -12, -3. I plug those guys in for -15, and then I factor by grouping. Take out a 2x from the first group, take out the -3 from the second group. I take that common factor out. I get my 2x minus 3 times x minus 6 equals 0. So we've done all that before. Now this is the step that we didn't do. Set each factor equal to 0 and solve. So 2x minus 3 equals 0, or x minus 6 equals 0. And I just solve these simple little 1 or 2 step equations. Add 3, divide by 2. I get 3 halves. Add 6, x equals 6. Okay? If your quadratic is not set equal to 0, so it starts in this form like this, we want to get it equal to 0 first. So we bring this over. We get it set equal to 0, so we can use the zero product property. And I look for a common factor, nothing to take out of a 4, 21, and 18. So I do 4 times -18. I get -72 all over -21. I'm sorry, two numbers that multiply to get -72 combine to get -21. So the signs will be different. The bigger one's going to be negative, and I found 24 and 3. Factor by, plug these guys in and factor by grouping. 4x squared minus 24x plus 3x minus 16 equals 0. Take the 4x out of the first, take the 3 out of the second, and I end up with 4x plus 3 times x minus 6 equals 0. That's where the zero product property comes in. Set each factor equal to 0 and solve. I'm going to subtract 3, divide by 4, -3/4, or add 6. So they would be my two solutions. Once again, if I plug these guys into the original quadratic and do the math, it's going to be true. Or even if I plug it in here, I'll get 0. Okay, that is what I'm finding. If you factor something out first, let's say we have the 2x squared plus 26x plus, sorry about that, that's supposed to be plus 84 equals 0. I recognize that I could take a 2 out, which makes my life a little bit easier factoring. I get x squared plus 13x plus 42 equals 0. And remember, anytime you factor something out, that guy comes along for the ride. And I figured what are two numbers that multiply to get 42, that combined to get 13 would be 6 and 7. x plus 6, x plus 7. What I want to do is, even though I have 3 factors now, I only really set the factors that have x in them to 0 because I can't really make 2 0 unless this guy's 0 or that guy's 0. So even though we factored it and there's a 2 there, I just do x plus 6 equals 0 or x plus 7 equals 0, and I solve those. So -6 or -7. That 2 we factored out doesn't really affect my solutions, okay? So make sure you understand that, where you set the factors that have x's in them equal to 0. All right, so just kind of looking through the steps here to solve a quadratic function. First, we want to do anytime we have a quadratic, we want to get it set equal to 0, right? We'll get it in standard form. 2, we're going to factor using any of our methods. Again, we spent a whole chapter on this. Hopefully you're decent with your factoring rules. If not, go back and review those. How do we factor? Take out a GCF, use the AC method. Remember, we could factor using a difference of squares. Look for a perfect square trinomial. Factor by grouping if there's 4 terms. Okay. And remember, as it kind of just pops into my head, if it is actually a difference of squares, like, well, actually I got an example down here. X squared minus 16 equals 0. This falls back into, we can still use what we learned in 9.3. If I add 16 and just take the square root of both sides, remember if there's no x term, we could do that. Or you could factor it and you'll get your answers. Let me go back up here and finish that up. So once we factor by using whatever technique we have, once factored, set each factor that has a variable equal to 0 and solve. And there you found the solutions to the quadratic, otherwise known as the roots of the quadratic or even the zeros of the quadratic. Okay, here's an example with the difference of squares. X plus 4, x minus 4 equals 0. Just set each factor equal to 0. So to make this 0, you'd get -4. To make that 0, it'd be 4. In this example here, I could factor an x out first. So then I factor this guy, right? My leading coefficient is 1. 2 numbers that multiply to get positive 24, same signs, I get -10, x minus 6, x minus 4. Now this guy is a variable, so this could be 0. This could be 0, so that would make it 6. Or this guy could be 0, which would be 4. So since we started with a cubic, we actually have now 3 possible zeros to the now it's not a quadratic, but to the cubic. Okay? So that's kind of our notes. I walked through, use your textbook. There's some good guide in there, some good examples you can use. And what you guys should be working on then is the 9-4 plan. Think about a plan. It gives you some a good starting place. And if you go to the 9-4 Form G, all good practice on factoring and solving. All right, I would spend some time doing that stuff. It's important. And it looks like there's 34 questions there, and then you have the standardized test prep you could be working on. Again, those answers are posted on the e-board as well, but do them first, and then you can check your answers. And don't hesitate to reach out and ask any questions on that, on whether it's this section or any of the sections that we've been talking about. All right. So that's our notes for today. And I'm probably going to, looking for the week, we'll, like I said, we're not going to go extremely fast here. I want to make sure we understand this stuff. So we have this stuff today, and tomorrow we'll work on the 9-4. You have test corrections you could be working on for the Chapter 8. You have your Common Core weeks that I gave you that were in the packet. That you can continue to work on. And if there's any extra time if you happen to finish this up, you could go to some of the review pages I gave you as well. But we're looking today 9